Diep.io is a cute little online game where you run around and you are this circle with a little cannon attached in the middle, and you shoot these little colored squares and triangles, and you can level up different abilities. Here I'll up my bullet speed and my movement speed a little bit there in the left corner. And you keep doing this and you level up, and you can interact with other players. In the right here you see a little scoreboard, and oh, there's somebody that's higher level. I gotta run away. And there's sort of drifty physics. If I keep shooting here, I will drift away from where I'm shooting. There's some bullet recoil. If I let go of the movement key on the right, I will drift for a moment before I come to a complete stop. And you can also notice all the little blocks kind of float around as we're all running around with each other here. And I enjoyed this game and wanted to write a Python version of it to play around with. So I'm going to walk you through sort of the iterations of my Python game and talk about the importance of objects as I go through. Here is my first draft of Diepio. If I press the left key, my little targeting indicator rotates to the left, or it rotates counterclockwise. If I press right, it rotates to the right. I also change color. If I press down, I change between yellow and blue. And if I press forward, I move in the direction that I'm pointed. There is no drift, and this is just a basic proof of concept. So let's see what the code looks like. So even though I've got very little working so far, I've already created a fairly complex class called my Diep critter. In the constructor, the init function right here, I pass in the surface. This is the drawing surface where I'm going to draw my critter. I pass in an XY coordinate and a radius, so how big it's going to be. I just set the color to blue, and this blue is defined up above somewhere. I'm not going to scroll and look at it right now. My X and Y values, I actually adjust to be the center of my object. I add the radius to them, so I'm at the center of my circle, because that's not how the rectangles actually work, right? A rectangle is defined by the upper left corner, so I subtract back out that radius to get the upper left corner for my X and Y values, and then a width and a height, and I just multiply the radius by 2 to get those widths and heights. I've got a move function that adjusts my X. It adds to my X value the cosine of my angle times 20. This is just arbitrary number I've decided is how far I'm going to move. And it also makes sure to update my rectangle, because I've got an XY value in my critter, but it's separate. My rectangle has a separate X and Y value of its own. So I actually just recreate my rectangle completely in the move function here. I rotate by turning an amount called turn rate. And I've got a function for drawing my little sprite on the screen, and a little separate code for drawing the heading circle, that little direction indicator. So I've got these 4 different functions. I mean, if I include the constructor up here for my Diep critter. And I actually copied this from other code that I had written. So I started with a nice little baseline. I also started with your basic Pygame stuff, creating a clock so I can control the frames per second, creating the surface that I'm going to draw on. I grabbed some colors right here, and I created my first Diep critter and just named it critter. I've got my main program loop. I just say while not done, and my game loops and loops and loops. I've got a big old chunk of code right here for event handling. You're still seeing like all event handling right here. In the future, I may pull this out into its own separate function, but for right now, it's just this big old mess of if and else statements inside of a for loop. So not exactly very organized. It's actually quite a bit of code, right? It's 92 lines for just that little circle that blips around the screen and doesn't do anything interesting. So let's see what gets added in next. My second draft has made the code a lot more smooth, right? So now I can move continuously. I've mostly adjusted the event handling. If you look at the move function, you'll notice it's exactly the same as it was before. Actually, I say that, I'm sorry. There's also a self.moving variable that I've added in, but other than that, it's exactly the same. What's changed is how I call the movement code. So I've added in a line right here, critter.update. So let's go look at what the update function does. So in my update function, I move and I rotate. And what's going to happen is these are actually going to activate. So the movement is going to activate if I'm holding down that movement key. So if I go to the event handling, I check and see here that the moving variable, this moving variable that belongs to critter, is either set to 1 or -1 if I want to move backwards. Jumping ahead just by 2 drafts, I've now got an automated following creature right here that just tracks me around the screen and tries to move towards me. Now, nothing special happens if it reaches me, except that it jitters around because it's trying to stay right on top of my location. So here is the class that I created for that following critter. I just called it an enemy critter, and it inherits from my original Diep critter. So if we go back up to my Diep critter, we see that I simply create the class with the word class and then the name of the class and then a colon. It's different when you're inheriting. I'll put some parentheses right between the name and the colon, going back down to the enemy critter. So there's my parentheses where I've said, hey, this object, this class here, inherits code. It basically copies code from the Diep critter. The other adjustment that I need to make that possible is this call right here to super. So there's a few different names for the class that you inherit from. One is the super class. And so that's this terminology right here. I need to call its constructor. So I say super.init, and I pass to it all the variables that it needs to construct itself, which are very, very similar to the variables that I need to construct an enemy critter. The one difference you might have seen as I scroll to the right is target. The enemy critter is going to keep track of a target that's going to pursue, and I don't need to pass that to the parent class, the Diep critter. What this helps me do is simplify my code in my constructor for my enemy critter. All I need is I set self.moving to 1 so that it defaults to always moving, and I set the target in a internal variable, an attribute of this class, so that the critter can remember it. Then when I call update, I override the superclass's update function, which means if I define a function that's the same as my parent class's function, it will call the child function, right? It'll call the sort of the lowest down function. It'll call the critter's update function and not the parent class. And that's important because I want to set my angle to be the angle to my target. I don't want to just, I'm not going to get input from the keyboard like I am with the player. So I'm going to modify this update function. So instead of calling that other one, I'm going to call one of my own new functions here, angle to target, which is a special function that I've added for the enemy critter. I don't need to put angle to target in the Diep critter because it's controlled by the player. The player can use his eyes to see what its target is, and the player can then direct its critter towards the target. It might be hard to see what the new addition is here, but I've made it so that the camera follows the player. Before, and you can go back in the video and check, I could move around to like the corners of the screen, but now you'll notice the screen is always centered on me. And the other critter still pursues me, but like I can leave it behind. I can leave it beyond the edges of the screen, and it'll slowly come back to me. To do this, I've actually separated the player out from the Diep critter itself. So I still have Diep critter, and it's very similar to what I had before. You'll see lots of same code here. But if I scroll down, you'll see a new object called player critter. And it also inherits from the Diep critter, just like the enemy critter does. The constructor is similar in that I mostly just pass upwards to my parent class all those inputs that I get, the screen and the XY and the color and the radius and the speed. I just pass those to my superclass, my parent class, by calling its constructor. And I don't need to do anything else in the constructor. There's no more code here. Now I am going to override the superclass's draw function because instead of drawing just wherever I am on the screen, now there's a little bit more complexity. And I'm not going to delve into all the detail of this. You can get access to this code online. I can share this with you. But there's now a POV X and a POV Y. This is the point of view X and the point of view Y, because now there's actually a camera that's going to follow around the different players. So I've created this new class, player critter. It's only got its constructor and one other function. Everything else is exactly the same as Diep critter. That's what it means to inherit. I basically just copy over all of its code unless I'm overriding something, unless I'm replacing one of that superclass, that parent class's functions. And in this case, I'm replacing the draw function with my own customized function right here. Here you can see we've added some of those experience items I just added them as little circles and random locations. I can't even pick them up or interact with them, but they're there on the screen. And it also helps me see better that my follow camera does seem to be working. I didn't add any new classes or objects for this food item, this experience gain. I'm just calling it foods and I'm putting it in a list. All I have here is a for loop that loops 10 times and it creates a Diep sprite at a random location and it appends it to the food list. So this is a super common thing that you will do when creating lists is you'll use a loop to append a bunch of new items to that list. And that's what I'm doing here. So I put all these Diep sprites into my list. And later on in the main loop, I have some code that loops through and draws those. So here we have that simple code that loops through, draws, and it also updates the food. Although the food doesn't actually do anything in its update function, but that's okay because I can still call the Diep critters update. I'm gonna go to that now. To move and rotate, because if my turn rate is 0 and if my moving variable is 0, then I won't move. And that's what the food does. But it makes it nice because later on I could modify that and have the food move around the screen. Jumping ahead even more, I've added a few things. I've added a barrier on the edge of the screen to show me where the edges are. I've also added some collision. You'll notice when this thing gets near me, it's going to actually push me a little bit as it tries to head towards me. And I can push it back if I want. I can shove it downwards a little bit. Right. At the very top of my program, I've got some global variables. I've got friction, I've got border shove impulse, and I've got world size. So friction controls basically how much I get slowed down as I move. There's some friction that reduces my velocity. Border shove impulse is how strong that green border on the outside shoves me back towards the center of the map. And world size is the height and width of the world. It's really nice to put a set of variables like this at the top of your program. And I say variables, I mean they're named variables and they have a value, but they're really going to be treated more like constants. These are going to stay constant probably throughout the course of a game. But I can change these if I decide that the friction is too much or too little, if the shoving impulse is too strong or too weak. I can just go up to the top and I can fiddle with these numbers and see how my code runs differently. I don't want to spread these out throughout my code because then they'll be hard to find. It'll be hard to make those adjustments as I'm trying to make the game better. I've added a handful of functions to my Diep sprite. That's the code you're looking at right now is inside of Diep sprite. Bounce off is one of them, where if two objects collide, they'll bounce off each other. And I borrowed some code from a Stack Overflow page, so I cite that resource right here. The code's a little bit complicated. It uses normal vectors and some dot products and things like this. I am not going to go into that. But it's code that is encapsulated, which means that it's put inside of a little capsule. So the word there that I'm using is encapsulate. And this is a key feature of object-oriented program, of this use of classes and objects. When we have complexity, we can hide it inside of a function that's inside of, hopefully, a class. And of course, we do need to write the code and understand the code, but once we get it working and we're confident that it's working well, we don't have to keep revisiting it. We don't have to have the rest of our main loop, for example, cluttered up with a bunch of vector arithmetic. We sort of hide it inside a function and say, hey, you know what? I trust that that function works. It's sort of like you don't have to be an electrical engineer to use your cell phone. Your cell phone works and it uses a lot of complicated technology, but it's encapsulated inside the phone itself, inside the processes of the phone. Not to say that it's not good to understand how the technology around you works, but this certainly simplifies our lives, and in many situations, we can get by without understanding all the complicated details of what's happening. Now, if you wanted to modify the bounce off function, you might have to dig in here and try and understand it, and I've done my best to write comments along the way to help with that. So we've added some health bars to our objects, and they can actually collide a little bit and damage each other. You can see my health going down as I get hit here. I'm going to run away from that. You can see that I can now collide with these experience food items, and they also have little health bars that show up when they take damage. I can't shoot or anything. I'm just running away so that I don't die here. I've added a whole bunch more variables at the top of my program. So I've got these all caps variables here, type critter, type food, and type bullet. So you'll notice, I'll scroll down to it in a second here. The critters, the Diep critters, now have a type, and it's going to have a value of 0, 1, or 2 for the critter, the food, or the bullet. And I use these right here, not because this makes it easier to read. I didn't show you any shooting, but I've got a default bullet timeout that I'm going to use. I can change this all at the top if I decide that it's too much or too little. I've got the number of hit points of the food, of the critter. I've got the radius, in other words, the size of the food, the count of the food. I've separated the player acceleration from the non-player character, that's NPC, from basically the enemy acceleration, just because I want to be able to run away from it faster. I have a new class that I've added called Health Bar. So you might think that this just goes inside of the Diep critter class, but I found that it was complicated enough that I wanted to make it a separate class. So it's got a drawing surface, an X, a Y, a width, and a height. It's got a maximum hit points, a total number of health points. And it's got a green rectangle and a red rectangle that are used to display visually what kind of hit points we have. You can set the X and Y values, and this just sets the rectangle's X and Y values. I can update the hit points. Now this also does some arithmetic here to make sure that the hit point total does not equal 0, and it adjusts that green health rectangle's width. And it's got a special drawing function all of its own. And I like this because this keeps the other classes and objects simple by separating out functionality that is separate. And that's one of the goals that we want to have when we create objects. It's part of encapsulation. We want to encapsulate any complexity in sort of isolated little places, little capsules, little containers. And the health bar class does that for me. What you will see inside of the Diep sprite, and this code right here is inside the Diep sprite's constructor, is that we do create a health bar, a self.healthBar variable where we keep track of the health bar. And we can also set it where we don't want to draw the health bar. We don't want to default draw the health bar for the food. That clutters up the screen too much. We've added some things like a take damage function, which also calls, if there is a health bar, it calls the health bar and updates the number of hit points, which is a really handy thing to have, right? We got to communicate damage to that health bar. Also, I'm going to go down to the draw function. The draw function now also has a little bit of code that draws the health bar, but it's just these 3 little lines here, and it also makes sure to set the positioning of the health bar correctly in case the Diep critter has moved. So here you can see we've added some shooting. The shooting is done with the space bar, which I regret because I have to take my hand off the mouse because the movement is done with the keyboard as well. But there's some shooting that works. It damages the food very slowly. The food has way too much health. But like I said, we have those little constants that we can adjust. We even have a little bit of AI here where the non-player character, the enemy critter here, will detect the closest object and will shoot at it. And it'll actually only shoot at, oh no, it'll shoot at me too. I thought it was only going to shoot at the little experience. And it kind of runs away from you a little bit too. You can see it back away. Going into the code, I'm at the top here. I can see all of my different variables. I think these are mostly the same as last time. The few that I've added are bullet speed, bullet size, and the amount of recoil. So the amount that it pushes you back when you shoot. I've added a bullet class, and the bullet, you might be a little bit surprised to learn, also inherits from the Diep sprite. So this is a really common thing, especially in games, where you have this base class, in this case the Diep sprite, that does a lot of special things like moving and drawing that a lot of other classes want to borrow from. And that's essentially what inheritance is. It's like borrowing code. We want our bullet to move, we want it to draw on the screen, so we're going to do a lot of things like that. We're going to pass to the superclass, the parent class, a lot of the usual stuff that we pass. We don't pass in an acceleration, you will see. I just set it to 0. These particular bullets are going to travel at the same speed all the time. Some new things for the bullet, though, are a dx and a dy. These are the velocity of this particular bullet, and that's going to stay the same, so we keep track of that as a separate variable. And we keep track of that it only belongs to this bullet class. It doesn't belong to the player or the food, because those things aren't going to be constantly moving. They're going to change their direction and things like that. The bullet also needs to keep track of who the shooter is. This is just mainly so that, well, 2 reasons. One is that we don't want the bullets to damage the person that shot them, even though they're going to overlap with their shooter briefly at the start. So they could collide with their shooter, but we don't want that to happen. They have no friction, they don't slow down. That's not actually how the Diepio online game works, but for now, that's how our game works. I override the parent class when I update. And then I do an interesting thing here. So first of all, I mainly just decrease this timeout. So I decrease the timeout by 1, so my bullet is eventually going to die. And then I do this right here, which you might not have seen before, super parentheses dot update parentheses. I'm calling my parent class's update function, but I want that to happen after I have done my timeout. So I'm gonna do my own special thing. The bullet is gonna do its own special piece of code here with the timeout. And then it's gonna say, hey, parent class, I wanna do my normal update also. So even though I say this overrides the parent class, it calls the parent class as well. So it still executes that code. So you can run some of your own code and then also still borrow your parent class code. I have done a very bad thing, and I will admit it to you. If I go to the very bottom here and check my number of lines of code, I am at 584 lines of code. There are at least 5 classes in this single document. This is way too much stuff all gathered in one place. So what I need to do is I need to separate these different classes out into different folders and different files in the same folder. So here I have finally separated all my Python files out into separate files. I've got main, of course, my file that I'm gonna run. I've got the health bar object in its own file right here. I've got a set of miscellaneous functions that I've just named funcs and thrown into a Python file. I've got the enemy, I've got the df sprite, I've got the player. I've actually got a whole file for constants. Let's just look at that for a second. So it's basically just all those variables that I had at the top of my main file, but now they're just in one little file over here. I've also got this all sprites list, and there's a whole bunch of things in here, including the screen width and height and a bunch of the colors. And I just throw all these in one place so that they're not cluttering up main. The top of main is a little bit cleaner now. I mean, a little bit cleaner. It still has all my imports, and there's a lot of them. It initializes Pygame, it includes the clock on the screen and a font object for writing text on the screen. It's still a lot of stuff here. It would be even more cluttered if I had all the constants there. Speaking of imports, right, I'm importing a lot more stuff. I gotta import the df sprite now, the player, the enemy, all this stuff that used to be inside of main is now outside of main. So I have to tell Python where that code is located and how to use it. So that's what all these imports do. And that's why I put them up there. So basically when I import df sprite, what happens is it goes and grabs this file right here, and now I can use df sprite. And you'll see df sprite even imports many of its own things, including everything from constants. It's nice to separate out every single different object that you have into a separate file. However, you will notice there's one place where I did not do that, and that is in df sprite. So if I go down to the bottom of df sprite, and this is a pretty long file, I also have the bullet class. Now the reason I chose to do this, and it's debatable whether or not I should have, the reason I chose to do this is because the bullet is only ever created inside of a df sprite. Since df sprite's the only thing that references bullet, I can keep it in the same file. And in some ways that's better organized, but in some ways it's not. Someone reading this code might be like, where in the world is the bullet file? If they're just looking at my folder structure, they're not gonna be able to find bullet.py, and they might be confused about where to find it. They might have to track it down throughout my code, which is kind of frustrating. But I did have a reason for putting it in there, and the reason was because df sprite's the only thing that uses bullet. If anybody wants to shoot, they call the shoot function in df sprite, and then that function creates a new bullet object. I also have a sparkle right here. This is a very simple little class. It, of course, inherits from df sprite. Now you might notice that when we import df sprite, we don't just say sparkle parentheses df sprite. We have to say what file are we getting that df sprite from? Well, we're getting it from the df sprite file. So we say df sprite dot, well, df underscore sprite dot, and then the name of the class. And it's fairly short. It has an update. It draws on the screen and sort of randomly changes its location. And this is to just add a little bit of animation when we pick up a power-up. So I think I landed on a power-up right away. You can see the sparkle happening all around me. And it's just these little X's that appear on the screen. This video has gone on more than long enough. So I just wanted to show you the most recent draft and show you some of the things it does before cutting it off for now. And I'll add more details I'll talk more about this and how it works and how you're going to modify it if you want to in class. Over on the left side, I've got power-ups that you can select by pressing one of the number keys. And the enemy sprites, the computer players, can automatically upgrade themselves once they get enough experience. The experience bar is up in the top middle. You'll notice it goes up as I run into these blocks and take damage. But I shouldn't do too much of that. So here I'll kill one and it goes up and up. And I can upgrade something there. So let me spend an upgrade on bullet damage, number 5. So you'll notice there's a second little green pip that shows up there to indicate that I have that power up. There's a leaderboard on the right, and I've named some of my different little AIs that I created for testing. There's power-ups are written just as text on the screen. I'm gonna grab shove because that's kind of a fun one. So shove increases how hard I shove. So I'm gonna shove and then run into this yellow brick right here, and you'll notice it go flying. At least more than it would have before. Yeah, so I kind of shove things far out of the way. Teleport teleports me to a random location. Let's see where that goes. Boop, and suddenly I'm somewhere else on the map. I cross out little critters that end up dying. Big Food is destroying everybody right now on the leaderboard. That's okay, because I'm not really trying to play. Oh, Big Shot is fun. I can get really big bullets. That's nice. Anyway, this is still a work in progress, but you can see a lot of the things that I've added in. Oh, the white circle around the center is my vision radius. Now, obviously, as a human, I can see further than that on the screen, but the computer players can only see within their vision radius. And by the way, I can switch the camera, who the camera's focused on. If I press the space bar, I'll go see what Big Food is seeing. And something is wrong with it. It can't decide where to go, possibly because it can't see anything. Anyway, that's all for now. And I hope this has helped you a little bit understand both the development process and how important objects are and how important they are to organizing your code.